Hi guys, today I'll be doing this Codechef Starters 44. I I am participating in a Codechef contest after a long time, like maybe 2 months or so. Let's see how it goes. I'll be solving problems of all the divisions. So I will start from div 4, followed by div 3, then div 2 and div 1. Hoping that this is the right order. Like this is the first problem of div 4 probably. Okay, let me check. Yeah, okay. According to a recent survey, okay, chef will be required to attend the master chef's classes for X weeks. Per week is Y coins. Total amount of money chef will have to pay. Wait, what? Just multiplication of two numbers. Or test this. Hmm. So yeah, this looks good. I mean, there's literally nothing to explain here. Just we are given the cost of per week and the number of weeks, and we just need to multiply them. Air hockey. Alice is playing air hockey with Bob. The first person to earn 7 points wins the match. Alice's score is A and Bob's score is B. Charlie is eagerly waiting for his turn. Minimum number of points that will be further scored in the match before it ends. Two, two, three. Okay. So again, just minimum of 7 minus x comma 7 minus y, I guess. Yeah. The attack of knight. While playing chess, Chef noticed it is generally advantageous for him if his knight attacks two or more of his opponent's pieces. Okay, this problem looks interesting. Take an empty 8x8 chessboard and any two white pieces, distinct cells, and place the pieces on those cells. Check if there exists an empty cell where he can place a black knight in such a way that the knight attacks both the white pieces simultaneously. Okay, so two positions are given to us, and just yes or no will be our answer. Okay, we know that. So if we don't know, the knight moves in an L shape. So like here the two positions are 1 comma 1 and 1 comma 2, so the knight cannot attack them simultaneously. 1 comma 1 and 1 comma 3, yeah, the knight can attack them. 1 comma 1 and 1 comma 4, no way. 1 comma 1 and 1 comma 5, yes. So okay, let's open a chessboard then. Yeah, maybe this one will work. Or I guess board editor will be better. So let's clear the board. Okay. So the test cases were, can't I draw something? So I cannot draw apparently. Is there no way? It's like okay, so for drawing I had to press the shift key, but earlier I was pressing the control key. Okay. So the two positions can be these or these, and this one will work too. So if the two pieces are any of these four squares, so like this is a valid pair and first and third is also a valid pair, and so I guess if the difference between their coordinates, if the sum of the difference of coordinates is 2 or 4, like if they are placed here and here, so if a knight is placed here, then these two positions, so these are all the 8 positions that will be attacked by this knight. So like if it is like 1, it is like 2 comma 5, right, and it is 3 comma 6, so the difference is 2. Hmm. And yeah, if they were placed like these, then also that will work fine. Yeah, so I guess yes, this is it. X1 Y1 X2 Y2. So if absolute value of x1 minus x2 plus y1 minus y2, if it is equal to 2 or 4, I guess, because the other positions will not work. Or so like this and this, these two will also work, no? Okay, so I cannot draw the arrow. So this one is 5 comma 5, no, 5 comma 6, and it is 2 comma 5. So the difference is, yeah, difference is 4 only. Our difference is 4. Then C out yes, else no. Yeah, we messed up something. Hmm. The inputs were hmm. X1 y1 and x2 y2, right? Y oh, okay. So either we are printing no in a yes case or yes in a no case. So let's think about the case where we are printing no instead of a yes. So like this is 2 comma 5 and okay. So this one is 2 comma 5 and this is also this is 5 comma 2 and the difference is 6, but there exists an answer. Okay, and what about this diagonal? So it is 2 comma 5 and this one is 4 comma 7. Yeah, the difference is 4, but I am printing out yes. There is no way, right? Yeah, there is no way to attend that. Oh, no. So their diagonal distance, like I can think about a few cases, but I mean I can write a bunch of if else and get to the answer. But is there some smarter way to do this? So this way, if their diagonal distance is 3, then we have an answer. Okay. So x1 minus x2, y1 minus y2. If d1 and d2 both are equal and d1 is equals to 1 or 1 or 3, right? Because 2 will not work, and yeah, maybe 5 will also not work. Yeah, 5 and 7, those will not work. So this is a yes case. Else, if like x1 and x2 both are equal, and absolute value of y1 minus y2 is equal to 2, or absolute value of y1 minus y2 is 4, then also it is a yes case. And there is one more case. First, wrap this thing in brackets. Maybe I could have googled it also, but okay. Still, one most basic thing was the both pieces should be in the same color of square, but their distance. Hmm. So this case and this case, these two are clear. Yeah, those two are correct, I guess. Hmm. Then the other case, if their diagonal distance is equal and equal to, for this one I have this, and yeah, what happens in this case? Yeah, this case is a problem. 2 comma 5 and 1 comma 3. So the distance is 4, and also in this case the distance is 4 plus to 6. How to do this? So like if their horizontal distance is 2, then their vertical distance can also be 2 or 4. No. their yeah their vertical distance has to be equal to 4. But am I missing something? So these are actually their horizontal distances. These are their vertical distances. So if h is 0, then like they are on the same file, then their vertical distance can be 2 or can be 4 only. V is 2 or V is 4, then it's good, else it's bad, right? Else if h is 2, then their vertical distance has to be equal to 4. And I missed one case here. If their horizontal distance is 1, then if then their vertical distance has to be 1 or 3, I guess. Okay, if their horizontal distance is 2, so horizontal distance 2, then their vertical distance has to be 0. No, can be 0 or 4, but not 2. Else, see out now. And if their horizontal distance is 3, then their vertical distance should be 1 or 3. Or V is 3. Yes, else no. So like in this case, this is valid, and oh, so that was not distance 4. So mm, can't draw that arrow. So this one and this one, like the distance is 4 in this case horizontally. So their vertical distance is 0. Can their vertical distance be 2? Yeah, it can be 2 also. If h is 4, then v is 0 or v is 4. No, v is 2. Then yes, else no. And else just no. For 1, 1 and 3 were working. For 3, 1 and 3 were working. For 2, 0 and 4. For 4, 0 and 2. For 0, 2 and 4. Okay, so maybe that was the pattern. But yeah, I think I'm missing one case. When their distance is 6. No, that is not possible. Yeah, that should not be possible. Still, when the horizontal distance is 1, vertical distance is also 1. Or vertical distance is 3. Right? So that square can be here also. Yeah. For x1 minus x2 equal to 0. Their distance should be 2 or 4 only, right? So this is a valid answer, or yeah, maybe that one will also be a valid answer. Yeah. For horizontal distance equals to 2, like this, the vertical should be 0. Vertical should not be 2, right? Vertical 4. This is 4. Vertical 2 is nice. No, that one is not good. Horizontal distance 3. So this is the 3 case. Vertical distance 1 or 3. Horizontal distance 4. Vertically 0 or 2. Ah, so there exists an empty cell. So maybe the cell that I am thinking of is out of the board. Yeah, I think that was the reason. Let's start with 1 and go up till 9. So I have to figure out all the 8 squares now. Hmm. I minus 1 and j minus 3, right? So let's say the knight is here. Then I plus 1 is here and minus 2. Okay. J plus 2 plus 1 plus 2 or plus 1 minus 2, I guess. And v dot pb. Okay. I plus 2 j minus 1 j plus 1 minus 2 minus 1 plus 1, and then just check if, okay, let's have two flags then. F1 is false, F2 is false, or even better, x comma y and v. If x is x1 and y is y1, then f is true. If x is x2 and y is y2, then f2 is true. So if f1 and f2, then p is true, and c out, p, then yes, else no. Hmm? Okay, so if it doesn't work now, then I'll just leave it. This should work. Jogging. Jogs every day to keep herself fit and active. She noticed that she burns X calories when jogging the first kilometer, and for k greater than 1, jogging the kth kilometer burns calories equivalent to the number of calories burned. Okay, so maybe some kind of DP. No. 1 2 2 1. Ah, I think modulo exponentiation. So yeah, 1 kilometer and 2 calories. Then 2 kilometers and 1 calories. Hmm. In this case, after 1 kilometer, calories burnt will be 1. After 2 kilometers, it will become 2. After 3, it will become 4, right? Yeah, after 4, it will be 8. After 5, it will be 16. So, okay. If n is 1, then yeah, just X is the answer. Otherwise, x plus equals to x, so it will for sure be more than 1. Then just do binary exponentiation, I guess. Modulo mod. Hmm. 8 to the power b, so x to the power n minus 1, I guess. Hmm. Wrong answer in one case. I mean, there are only 2 cases. So, that was probably very incorrect. Is this right? First day 2, the second kilometer 4. For the fourth kilometer it will be 16. Okay. So not like this. If x is 1, then x plus equals to x and n minus minus. But okay, so maybe it will work. And yeah, there's no need of that. So the case that I'm worried about is what happens in 1,1. I think that will be fine. And like 10,1. So yeah, that one should be. Yeah, that one was not the problem. Again, am I thinking about only the cases where x is 1 or 2? What about x is 3? First day 3, second day 6, third kilometer 12, fourth kilometer 24. Ah, so this doesn't matter apparently, and yeah, we should not do this. Okay, so if x is 1, then do n minus minus. No, x minus minus should be done in all cases. Then multiply it with x and then do modulo. This one is simply like finding out the pattern and nothing special. Yeah. Triple Xor. Given two integers n and k, number of ordered triplets ABC, satisfying the following conditions. Both are less than 2 to the power n. Like all the three numbers are less than 2 to the power n. All are distinct and their XOR is equal to k. And we have to find out the number of such triplets, such ordered triplets. And can be up to 20. Okay. Yeah, so this thing is understood. Okay. So let's say when k is 10, so its binary representation would be 1010. Mm, yeah, something like this, you will understand. And then we need to find out the number of such triplets. They should be less than 2 to the power 9. So let's say the value of n is, or let's just find out all such triplets first. 0 XOR 0 XOR 10. No, this should be distinct. So 1 and 11. Something smaller. I guess 2 and 8. Right? Because it is this and it is this. They want ordered triplets. Okay, so like shuffling is also a unique one. So one thing is that like one number has to be equal to, let's say C has to be equal to 1 left shift the log of k, right? So if log of k, like log to the base 2 of k, is greater than n, then the answer does not exist, I guess. Oh, so yeah, this is the condition, so k has to be okay. Can we traverse linearly? Can we? So if we want to get the XOR equals to 10, then let's say the number that we are choosing is 9. So in this case, the other numbers, the XOR of the other two numbers has to be equals to 3, right? Or like this. Now how many ways to get this 3? But I cannot traverse linearly. So this one is easier apparently. A bracket sequence S is called dense if one of the following is true. If it is empty or it is equal to this and the inner portion is also dense. Minimum number of brackets you must remove to make it dense. Okay, so this one and this one, right? Okay, like this and this. And in this case 0. In this case, so 1, 2, 3 and 4. And in this case I guess only 2. So is it just some prefix and suffix kind of thing? Yeah, I think so. Okay, let's solve that one first. Now or better to S. S plus equals to Si plus 1 and Si plus equals to hmm, let's say it is str. Okay, if str is the opening parenthesis, do p plus plus and answer equals to minimum of answer comma hmm, like minimum of or n minus minimum of prefix comma suffix of I plus 1, right? Yeah, then just see out answer. Here have answer equals to int max. But what? Okay. 5375 into 2. Ah, this should work. Yeah. Okay. So now the other thing remaining is this problem and these four. I'm not sure about how it's going in div 2. So triple Xor is the second most solved problem. Okay, and div C. Div C also it is fourth most solved problem. Okay, let me read this problem also. N hidden integer arrays of length n. We are given the max of each of these n arrays. Okay. He likes lower bounds and some other one likes upper bound. Least possible number of occurrences of pi across all arrays. Of I. Okay. Let's see the examples. Max of the whole array is given to us. Oh. So, okay, let me write it. So 3 means that there are 0, 1 and 2. Okay, what's the length? Length is also n. And there can be 5, 6 and like numbers greater than 3 also. But 3 is absent. Okay. 3 is absent. And for 0 to n minus 1, we want to find out the occurrences of phi, least possible and most possible. Yes, so in the first case it is 2, 1, 0. So occurrence of 0 would be, so the first array could look like this or that, but we don't need that. So let's say it is this. Like there has to be at least 1 0, right? And in the other array, yeah, here there is no 0. So the least possible occurrence is 0 and the most possible one is, wait, what? Least possible occurrence is also 1. So is it like we have to tell for each array? I mean that won't be good. So combined. So I was thinking that since there is no 0 present, so the least possible occurrence would be 0, but no, that's not the case. If it is present in one of the arrays, then the least possible occurrence is 1. But wait, what? Oh, so yeah, so since they wanted to minimize, they did not consider a case where, like, they did not put this case here. Instead of 3 comma 4, they could have think about 1 comma 1 also. So I think it is easier than the other one. But how to solve this? Once more, let me read the problem. These values must be computed independently. Okay. So if there exists even one array whose max is equals to I, like if there doesn't exist any array whose max is equal to I, then what will happen? Okay, so if there exists any one array whose max is more than I, then the least possible occurrence will be 1, right? And if the max of all the arrays is Mhm. Like if there exists some array whose max is not I, then the most possible occurrence would be n, right? No. Hmm. The problem is that their lengths can be 1 also. Oh, so these values, yeah, so max has to be that one. For 0, in the second case, they are saying that the least possible occurrence is 4. But how? So yeah, they are basically taking the sum of occurrences of zeros for most possible occurrence. So another problem is that I cannot generate all the arrays. But instead of generating, okay. So one way of thinking is that, let's say there is some array which denotes the occurrences of I combinedly in all the arrays. So I'm saying that 0 occurs at least once in each array. Similarly, 1 occurs at least once. 2, so basically all the arrays like V1 is 0, 1, 2, 3, 4. And similarly V2, V3, V4 and V5. And now the max of the 0th array is 3. So this 5 will turn to 4 because there is at least one array which does not contain this 3. Now this number can be anything, right? This can be 0 or this can be 1 or this can be 2 or anything, but this cannot be 3. So the main thing is that I can set it equal to any number, and that number will be useful when I want to maximize the number of occurrences, right? Like I can use it greedily. I can set that value greedily. Like when I want to maximize the occurrence of a particular number, then I will set it equals to that one. And if I want to like minimize the occurrence of a particular number, then I will not set it equal to that. Okay, so if I want to maximize the occurrence of 0, maximize 0, then this will be 0. And if I want to minimize 0, then I can set it equals to anything and it doesn't really matter. Okay, so let's say for now it is an underscore, it is a wildcard basically. Now it is a 1, so this simply means that there is at least one array which does not contain a 1, so it is 4. The max just simply means that that particular number is absent from the array and all the numbers that are less than that are present for sure. Then there's one array which contains all the numbers, so since it is 5, so I should not remove anything. Now it is a 0, so at least one array doesn't contain a 0, so decrease the frequency of 0 as well. Then there is a 2, so decrease its frequency as well. So this way, yeah, the minimum occurrence is 4 and the minimum occurrence is determined somehow. For 0 it is working, and the maximum occurrence of 0, so there are only 4 wildcards, right? Or yeah, there can be more. So yeah, all the values that are bigger than 0 are also eligible for a wildcard, right? Okay. So this 3 will give me exactly 2 more wildcards, right? This one will give me 4. This one will not give me any wildcards. This one will give me all 5, and this one will give me 3. Okay. So it is 8 plus 4, 12, and 2, 14. Plus, but 14 plus 4 is 16, no? Mm, so this 3 denotes that V1 is something like 0, 1, 2, and a wildcard and a wildcard. Similarly, V2, for V2 this is a wildcard, this one is also a wildcard. For V3 there is no wildcard. For V4 everything is a wildcard. And now for V5 this is there, this is there, and yeah, these are empty positions. So like we can see that the minimum occurrence of 0 is 4, 3, 2, 1, and 1. Okay. For the maximum ones, 2, 4, 6, 6 plus 5, 11, and 11 plus 3 is 14. Wait, what? 2 plus 4, 6, 6 plus 5, 11, plus 3, 14. Ah, okay. So these 5 will not be included because they has to be greater than 0. So each wildcard comes with some condition. Okay, so maybe I got it how to do this one. Let's have a vector of hmm, okay, or what to name it. Let's just say it is occurrence for now. So if v of I is equals to n, then just do nothing. In the other case, OCC of hmm, in the other case, let's have a count. and comma 0. So the count of this max plus equals to n minus um, n minus v of I, right? Right. And then some like empty positions plus equals to n minus v of I, right? Okay, but still, how to count the minimum fences? Should we have a number line? Hmm. Like in this case, there can be a 1, but since we want to minimize it, we are not saying that there is a 1. Okay, so maybe I see it. Let's initialize it with 0 and here do this. Yeah, and now for minimum and maximum ones, let's say minimum is n, then mi plus equals to occurrence of this should be the minimum one, and for maximum ones empty plus mi plus mm, not plus minus cnt of 1. I think there can be some int overflows as well, or mm, I'm not sure. Maybe there can be because yeah, 10 to the power 5. But I think yeah, this mi will not overflow. Yeah, yeah. This maybe it will. Okay, I really can't think of that. Let's see. Okay, cool. Alternating strengths. Spend his summer vacation playing with strengths. Likes alternating patterns, but he only likes the characters A and B. So he does the following. Starts with an empty string S. First appends A once to S. Appends B twice to S. Thrice, four times. Okay. Now chef takes the string formed by the first n characters of S and want to calculate its beauty. The beauty is calculated as follows. We define the value of a string A to be the number of positions such that AI is not equals to AI plus 1. Okay, yeah. And then the A, beauty of a string is defined to be the sum of values of all its substrings. All its substrings. Okay. Two substrings are considered distinct if they occur at different positions. Okay. You are given an help chef by calculating the beauty of the string. Beauty is the sum of values of all its substrings, and the value of a substring is basically the number of, you can say, the number of groups of same characters. So like if there are two groups of a particular character and one group of another one, then the value is the maximum of the two groups. So the maximum is 2. The value will be 2. So we are given only n, and that n can be up to a billion. So I cannot generate a string, but like how to calculate for each possible substring. Not only that, okay, so there are some patterns. So let's look at the case when n is equals to 7. String will be A, B, B, A, and B. So one thing is that the beauty of string from 2 to 7 will be like the value of string from 2 to 7, the substring from 2 to 7, and the value of substring of 3 to 7 will be equal, because these two characters are equal, no? So the beauty will not be affected. So like the only point to tell this is that we don't necessarily have to calculate the values for each and every substring. They will be repeating is all what I wanted to say. Okay, so how many times the value will be equals to 1, and what can be the maximum value? So for the maximum value, what we are basically doing is that we are adding up these numbers, right? Like 1 times A, then 2 times B, then 3 times A, then 4 times B. So like this, we are adding it up to, I don't know, let's say K, and the sum is becoming equal to N. So I basically need to find out the first K for which the value exceeds or becomes equal to N. So like some K into K plus 1 by 2 is greater or equals to N. Mm, I mean, I can do a binary search for this, but maybe there's some easier way to calculate it as like square root of N will give me something. Like square root of 7 will give me what? Square root of 7 is just 2, I guess. 2 point, I don't know, maybe 8. Like this is not a problem. I can find out the maximum value easily, either by doing square root or by, by binary search as well. So maximum value is, let's say, K. I mean that number is K, and that number basically just denotes the maximum value, right? So this is 1, this is 2, and this is 3. But 3 into 4 by 2 is 6, and which is less than N. So 4 into 4 into 5 by 2 is 10. Yeah, so 4 minus 1. Okay, so that maximum value will be equals to K minus 1, right? And let's say the length was equals to 10, then also, yeah, the value is just 3. Okay. Hmm. So then, hmm, and that maximum value will be possible only once, right? Yeah. Hmm. So in this case, the value is 3. In this case also the value is 3. In this case also, and in this case also the value is 3. But Now if I remove any of the character, so the character can be this, or it can also be this. So let's say I remove the character from the back, then it will become 2, will remain 2, remain 2. Now it will become 1, will remain 1, and now it will become 0, right? But we can remove the characters from the beginning as well. Like for each removal from the back, we can remove the characters from the front as well. Okay. This is not an easy problem. This one is let's Triple Xor is having many successful submissions, so maybe I should look at Triple Xor first. Somehow I think this first case in itself is giving us some quick hint. But what is that hint? Running 3 for loops, not possible. This third problem is alternating string. This fourth one is palindromes not allowed. String is good if none of the substrings of S. Okay. Okay. Given a string A of length n, rearrange A to form a good string or determine it is not possible to do so. Wait, what? This is it. Is this the whole problem? Mm, there should be some trick, right? So any case like this, where the length of the given string is more than 2 and it contains only 2 characters, so there is no way to arrange those 2 characters. Like if some string is A, B, so only 2 distinct characters are there. We cannot arrange it in such a way that the resulting string will not contain any palindrome. So what are the cases in which we need to output no? First I should find out those cases. Like this case, okay, so it is possible to arrange these characters. What is the case where we are given 3 distinct characters and we cannot rearrange them in such a way that the resulting string contains no palindrome? In this case, I think there is a way. So does this contain a palindrome? Yeah, I think it doesn't contain any palindrome. Does it? No. Yeah, it doesn't contain any palindrome. So what can be that one case? I mean, if the frequency of, let's say, B was 4 and A was 2, then have to put a C here. Cannot put a C or B. Have to put a A. So I think I should have started with a B, followed by A, then C, then B, then another A because I cannot put a C or B there. Now have to put a C, have to put B, then I need a A and it is not possible. So that was a problem case. So does this pattern work? ABC, ABC, A. Okay, maybe this is easier, or maybe not. Let's give it a try. Hmm, yes. Okay, now the character with maximum frequency. See out. Hmm, hmm. Okay. If answer dot length hmm, is so if answer's length is, let's first say it is 0, then if v of selected is less than v of j, then set selected equals to j, like just the maximum frequency character. Now if answer's length is 1, then if j is not equals to answer dot back minus a, right, and v of selected, but yeah, this is the problem. Okay, so maybe I can do something about that. V of selected is less than v of j, then set selected equals to j, else if answer's length is 2, hmm, if answer's length is 2, then this should not be equals to that, and j should not be equals to answer dot length minus 2, or basically if its length is more than 1, so all the else cases. Minus 1. Right, now this selected case is a bit problematic, so let's write a for loop just to set the value of selected as well. So if answer dot length is 1, Then if j is not equals to answer dot back minus a, I mean, mm, how to say this? So if it is 0, then just break out. If answer's length is 1, then selected should be equals to answer dot back minus a mod or minus a plus 1 modulo 97, I guess. Yeah, and then just break out. And in the other case, if selected is not equals to answer dot back minus a, and oh, not selected, should be j, and j is not equals to answer of answer dot length minus 2 minus a, like the last second character, then selected equals to j and break out. Okay, so here if v of selected is greater than 0, then just answer plus equals to selected plus a, else break out. Wait, what? What is that? Hmm. 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 What just happened? V is just 0. Wait, what? Oh, but still, this should be 26 now. Hmm. Is this a palindrome? Hmm. So let's think about, or maybe I should check it once more. And like it is not a palindrome, just to be sure. Let's see. This may or may not work. Most likely it will not work, but let's see. There are many test cases, so should work on at least half of them. Runtime error. Okay, that's strange. Let's see where can we possibly access an invalid position. So I guess this should not cause any problem. Here, okay, answer dot back minus a plus 1. Like the last character plus 1 modulo 7. Modulo 97. Or maybe I can do it like this. I think, yeah, this is a problem. Should not do it like that. Okay, so then do it like this. If it is A, then set it equals to B, or like set it equals to 2, I guess. No, 1. Else, just do answer dot back minus A minus 1, right? So if it is a B, then it will get set to A. Yeah. And if it is a 8, then I am setting it equals to B. Okay. And here, so if J is not equals to the last character or the last second character, then set selected equals to J and breakout. Okay. Then here, if answer's length is just 0, then there's no problem, right? Set selected equals to J and we are good to go. Just a character with the maximum frequency. If the length is 1, then just make sure that J is not equals to that last character and the selected value's frequency is less than V of J, and set selected equals to J as see if both these conditions are satisfied and also V of selected is less than V of J. Then do that. Let's see. Ah, so maybe for checking, so I think this is a problem. No? Yeah, it should not have been this. Oh, so yeah, this is definitely wrong. I should not check this. Let's move this checker function. Yeah, those two WS are probably because of that checking condition. Let's see if it works. Yeah, I think this should be. Yes. Okay. So 5 problems were in div A or div 1. 3 are done. Let's look at this problem as well. It has only 9 solves, but we are brave. Given two integers n and m. You also have an empty set S. Okay. An array A of length n, ai is less than m, and for each I, there are m to the power n such arrays in total. Okay, that's a scary number. For each of these m to the power n arrays, insert all of its longest non-decreasing subsequences into S. At what? So there are total m to the power n arrays, and we are inserting all of its longest non-decreasing, or basically let's just say longest increasing subsequences into S, and each value is less than or equals to m. Okay, now output the size of S. So like you said, it is a set, so I guess the duplicate values are not allowed. So longest non-decreasing will either way reduced down to longest increasing. Output the size of S, since the size of S might be large. Okay, but how can it be large? You said it is a set, so the values at max can be up to 1 to n, right? Note that since S is a set, stores only distinct values. For example, when n is 3, m is 2, the sequence 1, 1 is the longest non-decreasing subsequence for both these and these. However, it will only be present once in S. So the answer should be 1. Three, 1, 2, 1. So we want to find out the maximum size. How could it be large? There's only one possible array. M to the power n arrays, so 1 to the power 3. Size is n. Okay, size is n. Each value, yeah, each value will be this. Okay. In this case, 3 to the power 2, which means 9 arrays are there, and each of size 2, each of length 2 basically. So the longest non-decreasing subsequence can be 1, 1 or 1, 2 or 2, 2, something like this. Can be up till 3, okay. So we are not inserting the elements, we are inserting the subsequences. Wait, what? Isn't this easy? So just find out the number of longest non-decreasing subsequences using the m values or m numbers, and then print out the minimum of the number of arrays and the number of subsequences, right? Yeah, I think that's it. Now how to find out the number of subsequences, because yeah, because the number of arrays is kind of given to us, just need to compute the power, but for longest non-decreasing sequences, so we can think of it like this, that how many subsequences are starting from 3 or starting from m. So number of subsequences starting from m will be equals to exactly n, right? Yeah, those will be equals to n. Then starting from m minus 1 it will become tricky, because okay, maybe this one will also be equals to n only. Let's say the value of m is 3, the value of n is 4, and then I am asking for m minus 1, which is 2. There is nearly an hour remaining in the contest, right? Yeah. And the value of n is 4. So the longest non-decreasing subsequences starting from 2. One can be this, one can be this, then this, then this. Yeah, and then it is not starting from 2. Okay, so this thing is understandable. And okay, so this one, ah, okay, so I see. There is a problem. These can be more than n, because this in itself means 4 subsequences, right? I mean, one is this, other one is this, one is this, and one is that. Similarly, no, for this one, it has to be these many. Or, mm, oh, so let's not see those and derive those from these given force, right? So one would be like this, another one would look like this, then this. Okay, now one will be this, 3 comma 3, and I cannot insert a value here because that will exceed the size limit, but I can insert one here. So this way it became 4 plus this one is duplicated. Oh, so counting starts from here. 4 plus 3 plus 2 plus 1, it is 10. It is 10. For m it is n. For m minus 1 it is n into n plus 1 by 2, right? Now how much for m minus 2? And it is our base case also. So 1 comma 1 comma 1 comma 1. Right, now I can insert a 2, I can insert a 3 as well. So should insert both probably. Similarly here also I will have to insert both 3, 1 comma 1 comma 1 comma 2 and 3. And then here also I can insert both 2 or 3. And maybe I will have to put both. But here I cannot put both values. 2 comma 2 and 1 comma 1. I mean there was only one possibility and here there are two possibilities. Here is only one possibility and yeah, that one will exceed the size. 1 comma 2 comma 2 comma 2 or 1 2 3 3 1 3 3 3. Yeah, no other possibility. Yeah, I think this is it. Oh, I am missing one place. 1 comma 2 comma 2 comma 3. Yeah. So total possible cases are 4 plus 6 10 plus 6 16 420. For this one the cases are n into n plus 1. But that doesn't help at all, does it? Let's think about it from the view of P and C. So first of all, like this is possible, this case is also possible. So there would be at least um, the length is n, so n into m cases. So these are the minimum possible ones. Like these one will have at most one distinct integer, like exactly one distinct integer, so their size can be anything, but the distinct numbers would be at max 1 only, and so on till 3 comma 3 comma 3 comma 3. Let's have one more dot, right? And then how many will have two distinct characters? So for two distinct characters, let's fix one as, if the first number is let's say 1, then the other one can be n minus 1 or m minus 1 to be precise. And then if it is 2, the other number can be m minus 2. Can we, oh, so we cannot even traverse linearly. Okay, maybe there will be some formula. Then for 3, m minus 3 possibilities are there, right? Okay. Or hmm, so for length 1, there are exactly n possible subsets. No, there are exactly n possible subsequences or subsets. And then for length equals to 2, I have 1 comma m as a possibility, 2 comma m minus 1 as a possibility, 3 comma m minus 2 as a possibility. So basically m plus m minus 1 plus m minus 2, so on up till 1, and that will just reduce it down to m into m minus m plus 1 by 2 only. Then for length equals to 3, subsets will be like 1 comma 1 comma m, or 1 comma 2 comma m minus 1, 1 comma 3 comma m minus 3. So in this way it will be m into m plus 1 by 2. Right now starting from 2 it will be m minus 1, right? Yeah, and 2 comma 2 comma m minus 2, m minus 3, and so on. So it will become m into m plus 1 by 2 minus 1, right? So overall the sum is something like this, plus m into m plus 1 by 2 minus 1. Minus 1 only, right? Maybe I messed up something. Yeah, m minus 1 are D's, then m minus 2, m minus 3, so on up till 1. So not minus 1, minus m, I guess, because this is the sum of first m minus 1 numbers. Then later on it will become the sum of first n minus 2 numbers. So length equals 3 is basically just the sum of first m numbers plus sum of first m minus 1 numbers plus sum of first m minus 2 numbers plus sum of first m minus 3 numbers, and so on up till sum of 1, which will be 1. And then I can write it down as sum of m into m minus, so like sum of m minus 1 is just sum of m minus m, right? And sum of m minus 2 is sum of m minus sum of m minus this plus this minus 1. But that doesn't help. But that doesn't help at all. Maybe there is some way to calculate this thing. Let's Google that. Sum of first plus sum first n minus 1 natural numbers plus sum of first n minus 2 natural numbers. I don't know. Let's think about it. Hmm. Okay, so I think we can pre-compute that. We can pre-process that thing. This sum, yeah, we can pre-compute this thing. But what about length of 4? So it will be something like this. Now there are m possibilities, and also so like 1 comma length of 3, right? Yeah, 1 comma length of 3. Hmm. But for 2 it will not be this. I will have to subtract something from here. Minus sum of m, I guess. Right. Then for 3, length of 3 minus sum of m minus 1. I mean sum of m minus sum of m minus 1. Something like this. Okay. I mean we can recompute that thing as well, but till how long we will do so. It is literally like running a for loop n into n times. Is there some easier formula? Okay. So overall what I will be getting is that length of 3 or sum of m, yeah, it will be added only once. Then sum of m minus 1 will be there twice, plus sum of m minus 2 will be there thrice, right? And so on. And here, okay. Now length of 5, uh, 1 comma length of 4, 2 comma length of 4 minus mm, length of 3, I guess. Then 3 comma length of 4 minus this value minus this value, but that will, yeah, that will be added, not cancelled out. I mean, those will be some very very huge numbers. Yeah, the name is up to the point. Too many, I guess. And they are saying us to take the modulo. I'm not sure. Like if we take the modulo, I think we'll lose something because we cannot compare two values. Like which one is bigger or which one is smaller after taking modulo. Maybe I'm just thinking in the wrong direction. Because yeah, in the beginning itself I said that I will take the minimum of two values, but if we are taking the modulo, we cannot take the minimum. So the other two remaining problems are the alternating strings and this one triple Xor. I'm still not able to get the solution for this one. Okay, so let's think from scratch. Okay, let's say k is 12 now. So binary representation of 12 is 1100 and denotes k to the power n is the ceiling. Let's say n is, I don't know, maybe 4. So nums has to be less than 16 then. So 0 till 15 are possible. Now for the final outcome to be equals to 12. Hmm. So since it is a 0, okay, let's say for the fourth or for the first position, since it is a 0, so it can be like this or this, maybe only these two possibilities, right? I mean, we can shuffle the values, of course, like this is another possibility and this one is the other one. But overall, these are the only possibilities. Okay, then for the second bit also. So like if mm, oh, and we are talking about triplets only. So yeah, and then we can think about grouping them together. Okay, now let's talk about the case where the bit is set. So all zeros, then suddenly a 1, or all ones, or maybe 1 comma 1 comma 0 is valid as well. It is valid kind of, because sort of, no, no, it is, yeah, it is not valid. So I guess this is the only possibilities. These are the only possibilities. I mean, we can say that these are also possibilities, but overall, these are the only possibilities. So the numbers has to be distinct. So this thing is a bit tricky. And more importantly, so they are saying that we don't have to take the modulo, so that number of triplets has to be less. I mean, it will fit in a long integer. So I can group the values of each of these sets with any of these remaining 12 sets, right? But the distinctness is something that we need to take care of. Now, how to say? So one case is hmm, XOR is 0 and N is 3. So 0 till 7, all numbers are available. Or basically they are saying that so they mean that there can be only 3 bits. at max. Okay. So for k equals to 0, that means this case. Right. Now for 0, we had these two things. And similar thing will come out for the third bit as well here. The answer is 42. So basically we are saying that 8 plus 8, 16 to 16, 32 only, no? No? 10, no. One XOR 2 is 3, 3 XOR 3 is 0. What are those other cases? So in this case, when k is 1 and n is just 2, so that means there can be at max 2 set bits, and it will look like this. So for the 0 case, oh, so but still the possibilities, okay, so I think I can generate all the possibilities for this case. So here for the first case, these many are possible, and for the second case, I mean for the unset bit, these are the possibilities. So one number, I mean one triplet would be 0 comma 2 comma 3. Other triplet would be 0 comma 0 comma, oh, so this case will have to be removed. Okay, let's include it for now. 1, and then 2 comma 2 comma 1, and then 2 comma 0 comma 3. Similarly 1 comma 3 comma 3, and then 1 comma 1 comma 1, and that case is duplicated. It will be 3 comma 1 comma 3, and so on. Out of 16 only 3 has to be taken. Out of 16 only 6 to be taken. Oh, oh, so now I got this case. So 4 into 4 into 4, yeah, and multiply this whole thing again with 4. So it becomes 4 to the power 4, which is how much? 2 to the power 8, which is 256, I guess. And if I just multiply 16 into 16, you have 256. And out of those 256, we are taking only 42. Two to the power 9 is 512. 9 means 4 to the power 9, right? Or maybe 4 to the power 10, basically. Yeah. But that will be a huge number. Like it will be 2 to the power 20 basically. And what's the value of 2 to the power 20? But what? 1048765. So how are these two values related to each other? I mean, I just need to find out those duplicate values. Then I'm good to go. Binary representation of 100. How would that look like? It is just 64 plus 36, no? And 36 is 32 plus 4. So this bit is set, this one isn't, this one isn't, this one is, and this one is. 6 plus 7, 8 and 9. And the other case was like this, 256 and 42, where 256, where the value of k was all zeros. How to find out the value of those duplicate triplets? That is a challenge. I think I tried writing the duplicates also. Yeah. So I was getting a duplicate every 4, 5, 6. Yeah. So this is the seventh value and I've got a duplicate. And like 2, 3, and then this, and this, and this, and this. So after one triplet, 2 are of no use. Okay. And after one more, 4 are of no use. So if I do it like this, 2 plus 4 plus 8, I guess, then 16. I mean, that doesn't make sense at all. Or does that hold for this case? 2 plus 4 plus total are 16 only, no? So if I add 8 here, then I'm basically left with 0. Or this will also be subnormal. Hmm, I don't know. Hmm. So the third bit can be 0 or 1 only. So if it is, hmm, if it is a 0, okay. So let's say this is A and this will be B, so it can also be 0 or 1, and for C also it can be a 0 or a 1. And then the other bit can also be a 0 or a 1, right? And now the third bit can also be a 0 or a 1. Similarly, and here as well. Now for one such value I have 7 other possibilities. For each of those 7 I have 6 other possibilities. So it turned down to 42 like that. Maybe yes. Hmm. Is this the answer? But I think that X is somehow related. Whoa. So, yeah, this value of K was not required in order to get to the answer. So yeah, I think this is it for this round, for me at least. Just at the time when I was losing the hope of solving that problem, I somehow pulled the rabbit out of the hat. And this alternating string problem is also quite doable, but yeah, I think this one is also doable. I think I wasted nearly an hour for this problem, Triple Xor. And after that, I just had to, kind of realize a small thing like this. So the key observation was, let's say we are having some number which has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on up till, let's say, 19 bits. Then a triplet can have, like, these are the bits of a triplet number, right? Then each of these three numbers, A, B, and C, can have the zeroth bit as set or like not set, right? It can be 0 or it can be 1. And if we do it like this and create all possible triplets, we will end up getting something like this. So you can, like watch the video again and see how I generated all these values. And after that, like for this one number, out of these 8 values, I can pick only 7 of these because this one value is already used, right? And for each of these values, like one value is already reserved, we can say, for A, and one value will be reserved from the remaining 7 ones for this B. Then the remaining values will be 6. Those 6 values can be any value from all these values which are not equals to A and B, basically. So this way we can count out all those values, and those all those values will end up something like this, like, yeah, 1 left shift 10. So how many these values will be? These values will be 1 left shift 10, then just n minus 1 into n minus 2, which is this into this, n minus 1 into n minus 2 for each of these. So this is how I solve this problem. And the other problems, so let me quickly go over my solutions. This problem not allowed. Yeah, in this problem what I did is that we were given some string, so let's say it can be any string. So there will be some count of occurrences of each character. So let's say why not take the example but, where it's not allowed, palindromes not allowed. So let's say this is so this is the given string. Now first I counted out all the occurrences or the frequencies of each character. So the frequencies are these. Now how I solved is that first I will put the character which has the maximum frequency, so that is A, and then I will reduce the frequency of A by 1, which is 2 because it is used once in the answer string, right? Yeah. Now I will pick any character which is not equals to the last character and has the maximum frequency. So in this case we can pick either of these two, B or C. Let's say we choose B, reduce the frequency of B by 1, then pick a character which is not equals to the last two characters and has the maximum frequency. So in this case only C is remaining, right? We cannot pick B, we cannot pick A, only C is remaining. Reduce the frequency of C by 1. Then similarly we cannot pick C or B now, so we have to pick A, then we have to pick B, then again C, then again A, then B, and so on. We can generate our answer. So in this way, if we are able to find out any answer, then we are good to go, and otherwise we will have problems and we'll just print out -1. So where's my code? Okay, let me open it once more. And yeah, so you may think that how I figured out this thing, that first we will put the character with the maximum frequency, So this thing you can observe, or they have given a small hint also, that there should not be any there should not be any palindrome of length greater than or equals to 2. So just think about all the palindromes of length 2. So like this can be a valid palindrome of length 2. There cannot be any other valid palindrome, like either a comma a or b comma b or c comma c. The main point is that there can be only one distinct character in a palindrome of length 2, right? Now for any palindrome of length 3, there can be at most two, at most two distinct characters. So like this is a palindrome of length 3, then ACA, for example, this is also a valid palindrome of length 3. So if I just try to remove these two palindromes, like palindromes of length 2 and palindromes of length 3, then automatically the final string will not contain any palindromes of length more than 2. A problem similar to this one was asked in a Kickstart round also, and there I think the palindromes of length 5 or more than 5 were not allowed. So that problem was, I mean, that was different than this one, but kind of same also. But to solve that problem, we need to use DP, and here the constraints were loose as well. So I mean, not loose, but were allowed to do it like this. I mean, we can linearly traverse here and find out the character which has the maximum frequency and which is not equals to the last two characters. So this way I'm checking if it is equals to the last character, or this one, this condition will check if it is equals to the last second character. This is the last character, this is the last second character, and this is condition is checking the frequency. So if the frequency of my currently selected character is less than this new character, then set it equals to j, selected character equals to j. And if this frequency, like if the selected character can be taken, then only add it to the answer, otherwise no need to take it and break out. At the end, if the answer is equal to n, like the length of the answer is n, then print out yes and print out the answer, otherwise print out no. So that was it for this problem. Now let's talk about this one, Atleast and Atmost. So yeah, this problem was related to max, and I think you already know about max. Like what is the max of an array? They have defined it here as well. Max of an array is the smallest non-negative integer that is not present in it. So let me just quickly go over my solution. Can't I see my solution here? I have to open all the solutions from the profile page. So how I got to the solution of this problem, for that you can just go to the video at that moment when I was solving this problem and see how I solved it. Here I can just don't know what to even explain in this code, but let me try. So first I am having some array in which will be basically counting that. So like one array will be something like this. Here the value of n is 5. So initially all the values are equal to 5, and now I somehow have to reduce these values. So By reducing, I mean if reducing the suffix basically. So if I reduce this value by 1, then I will have to remove all these three values as well. So what I did was I initialized it with 0 and then had a variable called p which was initialized to 5 or basically n, and then what I did is just that, yeah, here that vi or the max of that array. So if the max of some array is 2, then I set it equals to -1. If the max is 3 of some array, then reduce this value to -1 as well. Or if there are two arrays such that their max is equals to 2, then I set it equals to -2 and so on. And there were some empty slots as well. So yeah, at the time of solving the problem, I was explaining what the empty slots are and just add up all the empty slots. And then for printing out the minimum values, so you can see that p was basically mi. So it was initialized with n. Then I am adding up those negative values, so the value of mi will be reduced through this statement, and the minimum occurrences can be printed out here and the maximum ones. And this count I basically denotes that, yeah, so this basically denotes that how many, I think it should be, yeah, so how many empty slots are such that, so okay, let's say one array is having 3 empty slots, another one having 4, and some is having 2. And now these empty slots basically denotes that, mm, let's say the max of an array is 3 and n is 5, then 0 1 2, these three values are fixed, like these have to be present in the array. The remaining two are empty slots, but since max is 3, so these two values cannot be equals to 3 as well. So count of 3 just contains this thing, n minus vi. Vi is basically max, so 5 minus 3 is 2. So yeah, you can see that it is, I mean inside 3 I am adding this 2, like 2 empty slots should not be printed out when we are printing out the maximum possible slots for number 3, for I equals to 3. So here I am adding that minimum occurrences of I in the empty slots and subtracting those empty slots which cannot be equals to I. Okay. Now, okay, so this problem was, I guess, a very easy problem. Could be the third or fourth easiest problem, I would say. So I I don't know. I have solved many similar problems nowadays. Like maybe 3 or 4 recently I have solved similar problems. So what I did was just that I had a suffix array which was storing how many closing parentheses are there in any suffix of this string, and then in another for loop what I was doing was just that, mm, so they are talking about subsequence, right? Yeah, basically any sequence. So that sequence will be having some, that final sequence will be having some opening parenthesis and some closing parenthesis, but the main thing is that all the opening parentheses will be coming before the closing parentheses. So we can calculate these opening parentheses on the fly, right? Like when I am processing mm, this first opening parenthesis, I will ask how many closing parentheses are there in the suffix string. So in the suffix string, I can see 5 are closing parentheses. So the minimum of these can be a valid pair, right? So a pair will have 2 parentheses, right? So there will be 2 brackets which we don't need to remove, and all the other ones we'll have to remove, because we are saying that in the final string we are having only one opening parenthesis and one closing parenthesis. All the other ones we'll have to remove. So currently it will be equals to mm, 10 minus 2 equals 8. So the answer will become 8 for now. Now when I process this closing parenthesis, now I will check for minimum of 1 comma 4 into 2. So again this will be 10 minus 2, basically 8, again of no use. But then I will be having 2 comma 4 into 2. So this will be different. This will be 10 minus 4 equals to 6. So here 2 denotes that in the prefix string I am having 2 opening parentheses, and in the suffix string I am having 4 closing parentheses. This one, this one, this one, and this one. So out of which, like if I combine all the opening and closing parentheses, then I will get only 2 valid pairs and will multiply it by 2, and I will get 6 as my new answer. So I will update the value of answer as 6. Similarly, you can traverse the whole string and you will find out the answer, and something similar I did in the code as well. So yeah, here I am counting out all the closing parentheses in any suffix string. And then these are the opening parentheses counted in the variable p, and here you are just so minimum of opening parenthesis and closing parenthesis in the suffix string, and in the openings in the prefix string into 2. So this will give me the all the valid characters that we don't need to remove, and I am subtracting it from n. So it will give me the number of characters that we need to remove, and the answer will be set equals to minimum of the both the values. So yeah, this was it for this problem. And then Triple Xor I have already explained. Jogging, I don't think I can explain this problem all that well, because okay, so I can try. Like this is a very math kind of problem. So the main thing, like I can explain the code itself. Like the code is self-explanatory. So I just figured out the power of 2, because each time we are just adding up the previous calories burnt, right? So initially if only 1 calorie is burnt, then the next time it will become 2, next time it will become 4, 8, 16. So we are just multiplying it by 2, right? We are just multiplying it by 2. So how many times we will multiply it? So for that we can just figure out using this power function, right? A to the power b, 2 to the power n minus 1, and then at the end we will multiply it by x, because initially if it is x, if x is 1, then only we are just multiplying it by 2, but if it is x, then like initial value will be changed, and similarly the all the other values will be offset by x basically. So at the end we'll just multiply it by x, take the modulo and print out the answer. And attack of knight, this problem, I don't know, there should be some easier way, but how I solved this problem is that I figured out all the like I first put the knight on all the squares of the chessboard, and then hmm, okay, let me open the board editor. And yeah, so I put the knight here, 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 and like all over the board. And then I figured out the squares on which it can attack. So like if it is standing here, then it will attack these 8 squares. Right. Now what I did is just that if if the given 2 points are from these 8 points, so we are good to go. The knight can attack both the pieces, and if they are not equal, like both the points are not in the set of the squares that the knight is attacking, then we'll just print out no. So this way I just checked for all possible squares of the chessboard. And maybe the thing that was wrong with my earlier course was that maybe I was just thinking about some illegal position. So like I was printing out yes for this case as well, but this is not a valid case, right? If the pieces were here, then we can say that this is a valid square, or this is also a valid square. But here there is no minus a or some other part. Okay. Now air hockey. So these problems, I think the first two problems were pretty easy. Just the minimum of 7 minus first number and 7 minus second number was our answer. I think there's nothing to explain in this problem. Yeah, and these explanations are good in itself. And similarly, the biryani classes was, I don't know what to say about this problem. Just a multiplication of x and y was the answer. Okay, so this was it for this round. And I think I did pretty decent in this round. Yeah, rank 70. And maybe there were many participants in Div A. I guess there were close to 200 participants. Yeah, 148. I was in top 50%, I would say. So yeah, this was it for this round, and I'll see you in the next one. Bye.